Okay, so the following section is on how to multiply polynomials. Now we're going to be applying the distributive property, which says that if you've got a times b plus c, that's ab plus ac. We're going to be applying that once or multiple times to expand our polynomials. So I'll show you what I mean by this. So here's the question: expand. So maybe example A. Pen's still switching to some weird color for some reason. Okay, 4x cubed times 5x squared minus 2x plus 5. Okay, so what I want is I want to have a sum and difference of terms. I don't want to have things multiplied. We'll see that later on in the course. It's going to be the other way around. We'll have terms added up and subtracted, and we'll want to write it as a multiplication of simpler polynomials. So here's the other way around. I just want to expand this. I want to multiply this out. So you can think that I have like something that's like an a, that's like my a, and this would be, I don't know, it really wants to write in red. Okay, this is a plus b plus c. Okay, everything's a plus in the sense that when you have a subtraction, it's like plus the opposite of the term. So minus 2x is plus minus 2x. Okay. Oh, maybe I should have written down C, other letters here, not use A. So B, C, D, something like that. Okay, so ultimately when I'm going to multiply this out, I'll get AB plus AC plus AD. Okay, so I have to multiply A by B, so that's 4x cubed times 5x squared, so that's 20x, and here I'm applying the product rule for exponents, so x cubed times x squared, I have 5 copies of x overall, so as in 3 plus 2. After that, it's 4x cubed times, so here's the thing, right? You have to consider this is almost like plus minus 2x here. Okay, so 4x cubed times plus minus times minus 2x, that's going to give us minus, or if you prefer, plus minus 8x to the 4. But usually we don't write plus minus 8, we write minus 8. Okay, x to the 4. And finally, 4x cubed times 5, that's 20x to the 4. Okay, so obviously when you're going to write your solutions, that's the only part you need to write, right? Everything I wrote around it was just to show you how to, the logic behind the arithmetic operations that it just did. Okay, and then I have my final polynomial that's all expanded. So here's another example. Now I have 4x cubed plus x, okay, that polynomial times another polynomial, 5x squared minus 2x plus 5. So it's almost the same example as before, but there's this extra plus x in the first polynomial. But it goes the same way, so I'll do things slowly and show you how you can use shortcuts later on. But here, this is as if this is all of that is my a, and the other part is like b plus c plus d. So I do a times, so see, I would do a times 5x squared, okay, plus a times minus 2x plus a times 5. But then I have to apply the distributive property again. So I need to, so this is now like my a, and this is b plus c. So I need to apply the distributive property again. So I multiply 5x squared by 4x cubed. So I get 20x5. 5x squared times x, 5x cubed. And I do that again. This is like my a, this is like b plus c. So minus 2x times 4x cubed, that's minus 8x to the 4. Minus 2x times x, that's minus 2x squared. And finally, 20x cubed plus 5x. So I've applied the distributive property twice, and my final answer, for my final answer, I should group like terms. So I've got one term that's of degree 5, one term that's of degree 4. Here's a trick that you can use so that you don't forget any. Well, what you can do is count how many you have. We have 1, 2, 3, 4, 5, 6 terms. We should end up with 6 terms afterwards. That's one way. Sometimes what I like to do is the terms that I've used, I try to regroup them. So this one I'll circle it. This one maybe I'll put a square around it. But you see I have got 2 terms x cubed. I could maybe put a triangle or something. But I'm gonna add those 2 up, right? That's 25x cubed. Sometimes you can use, minus 2x squared. I could put a little symbol like this on top of it, just to say that I've used it. And here we go. That's our final answer here. Okay. And it gives us a polynomial of degree 5. Here's also one thing. Okay, so we're gonna look at the previous example from a different perspective. Sometimes I don't want to have all the terms. Okay, sometimes I'd just like to figure out the constant term. Sometimes I just want to figure out the leading term. In calculus, that's often something I want to do. Okay, so I don't really want to have all the terms. I only really care. Okay, I only care about the first one and maybe the last one. Or actually, what's the constant term here? That's tricky here. Not necessarily the last term. I want the constant term. So the constant term here, 5x is not the constant term. Constant term is sort of hiding at the end of this polynomial. It's 0, right? That's the constant term. So sometimes I want the first and the last. So how do I get those without multiplying everything out? Is that possible? Well, you'll realize that, for example, if I want the leading term, okay, what do I need to do? I need to multiply all the highest powers of x, right? So this 4x cubed ultimately is going to be multiplying 5x squared sometimes down the road. You see that it happened right there when we multiply these two together in order to get the 20x to the power of 5. So I just need to spot in each polynomial the term of highest degree, and those are the ones that I need to multiply in order to get my leading term. So I didn't have to multiply everything out to find that. I can just spot the terms of highest degree among the polynomials I'm multiplying. And same goes for the constant terms. Well, the constant term, there's only one. You see, to get the constant term, I need to multiply the constant terms of each polynomial. Now, the constant term of the first one is 0. There's a little 0 hiding here, so it's really 0 times 5, so that's why it's 0. Okay? So let's see if you understand this. Here's an example for you, and an exercise for you to work out, okay, on your own, and then you can pause and unpause and see what the answer is. But here's a multiplication of 3 polynomials. Okay, so try to figure out what it gives you when you expand all this, and figure out a way of calculating the leading term and the constant term without having to perform the entire multiplication. In fact, maybe you can start by that. Try calculating the leading term, the constant term, and eventually expand it all to see what the entire polynomial is, and you can check your answer this way. Okay, so pause and try to do this exercise on your own. Okay, so to multiply this, you see, I'd have to do, well, actually, maybe, like I said, let's start with finding, just without multiplying everything, let's find what the leading term is. So the leading term is obtained by multiplying the highest powers among all the polynomials we have to multiply together. So I have to multiply 4x plus 1, so 4x is the highest one, 3x here is the highest one, x here is the highest one. So by multiplying those together, I'm going to get my leading term. And for the constant term, I need to multiply the 1 with minus 1 with 1 again, and that gives me minus 1. And when I expand it all, I can verify that my leading term and constant terms are 12x cubed and minus 1. If I expand it all, you see I can do 4x plus 1. Maybe first start by expanding the multiplication of the last two polynomials, 3x minus 1 and x plus 1. To show you how I can do this slightly differently from the previous example, let's take a look at example B again. So in example B, you'll realize that to get every term that's present, okay, ultimately I had to multiply this term by this, by that, by that, and this term by this, by that, and by that. So that's how I got 2 times 3, 6 terms overall. Okay. So I can do the same thing here when you multiply, okay? You could say it's going to be 3x times x, and then 3x times 1. So 3x times x is 3x squared, 3x times 1, 3x. So that's essentially the same thing as doing 3x times x plus 1. Okay? So I'm going a bit faster here. So really the step I've done here is I've done 3x times x plus 1, but I've done it in one shot. I didn't write it down, I just calculated it immediately. And then after that, I'm going to do the same. So here, you have to realize this is plus minus 1 here, right? So the minus 1 is going to multiply x and 1. So minus 1 times x, minus x. Minus 1 times 1, minus 1. So what I've really done here is minus 1 times x plus 1. Okay? And I'm going to do the same to expand it all. So maybe, okay. To expand it all, I need to multiply 4x with this, with that, with that. Oh, now I realize there's 3x and minus x. So before doing this, to be smart, I should really group like terms. So I just realized this. So oh, there's a little 3x squared missing here. I forgot, right? It's 3x times x, so 3x squared. So 3x squared plus 2x. So I'm grouping these two terms together. 2x minus 1, okay. And now I'm going to multiply 4x with this, with that, and with this. So that gives me 12x cubed. That's my leading term. 4x with 2x is 8x squared, and 4x with minus 1 minus 4x. And then I'm going to do the same with 1. So it's going to be 1 times 3x, 1 times 2x, 1 times minus 1. So essentially, when you multiply by 1, you're just not changing the end result, the result of the multiplication. So I just need to copy back 3x squared plus 2x minus 1. And notice I get minus 1 for my constant term as expected. And finally, I can just group like terms together. Oh, I've got 8 and 3, so 11x squared minus 4x. Minus 4x plus 2x is minus 2x minus 1. And that's my final answer.